Hello people. Today we're going to do some exponent questions. First we're going to start by evaluating just some basic ones. We'll review what 5 squared means. Remember it's 5 times 5, so it's 25. Don't do 5 times 2, so it's not 10. And it means that exponent means times by itself twice. If you do a negative, it still is positive. 2 negatives make a positive. But if you have a negative out front, that stays negative. If you have a negative exponent, it doesn't make a negative number, it makes a fraction, 1 over 25 in that case. And now we'll switch to an odd power, say 5 cubed, that means 5 times 5 times 5. If you had it to the negative power, it's 1 over 125. Alright, if you have a fraction cubed, you can just cube the top, cube the bottom. And if you have a negative exponent with a fraction, you can flip the fraction because it means reciprocal to have a negative exponent. Right, just another way of looking at it in red there. And as usual, if you want to look at anything for a little longer, pause the video and convince yourself that something is true on there. So in this case, if you have an odd power, negative, in the bracket, it actually stays negative because you have 3 of them. Negative, negative, negative comes out as negative. Alright, now we're going to try some fractional exponents. So to do this, we need to know our little radical property there. You call it flower power or whatever you call it to remember it's the nth root. So we're trying to figure out the cube root of 125 in this case. We know that that's 5. Then we square it because there was a 2, so we're left with 25. If you had a negative exponent but with the same fraction, you just flip it. You go 1 over that power. It's still 25 on the bottom, so now it's 1/25. And similar idea, but this time we have a different power of 4. So once we get the 5, we'll raise it to the power of 4, and that negative just stays out front because it wasn't inside the bracket. We can check that 5 to the 4 is actually just 125 times 5 again, so it's 625, and the negative is out front. Alright, now switching gears to some simplified questions. So this time there are going to be some variables. So let's say you're trying to square 5x cubed. Remember that actually means you're timesing by itself twice. So you could expand it out like that, or you use the exponent laws and recognize you apply that 2 exponent to everything in the bracket. You get 25x to the power of 6. Alright, this time we're going to do one that has a fraction in it and 2 variables, x and y. Again, you basically just apply that exponent to everything that's inside. So you go 2 cubed, x cubed, and then y to the 4 times 3 because we use the power of a power rule. So you have to multiply. Similar on the bottom, and now we evaluate some of that stuff. So 2 cubed is actually 8, and 5 cubed is actually 125. And then we have to kind of combine x's and y's there. So on the top you had 1x, on the bottom you had 3x, on the bottom you had 6x. There's a little explanation of why that is. Another way to think of it is that you're just subtracting the top from the bottom power, and you're left with negative 3, which means it hangs out down on the bottom in the denominator. Alright, so here's another fraction, and this time we'll put a negative exponent up there. So remember that a negative exponent means to do 1 over that thing. So when you do 1 over a fraction, if you remember what dividing by a fraction means, that means you multiply by the reciprocal. So basically you can flip that fraction upside down and put a positive power, apply the 2, 7 squared is 49, 3 squared is 9, and so on, and then you combine. On the top you had 10 b's, on the bottom there were 6 b's. You end up with 4 b's overall. Alright, the last one. It's going to be one of those big ones with a negative exponent on the top, and we'll put a positive exponent on the bottom. First thing you usually want to do is get that thing with the negative exponent down on the bottom. The stuff in the bracket stays exactly the same, but the outside power becomes positive 3. Right. Now we just apply all those exponents. 3 cubed is 27, negative 2 times 3 is negative 6, and so on. And check on my calculator that 27 times 25 is 675, and that goes on the bottom. Notice I flipped those, the x to the 6 and the y to the 4 up to the top. They became positive powers when they're on the top. And the last thing is to kind of condense this down into just x and y. If you don't want them on the top and bottom, we can simplify. And again, we can think of it as subtraction. 6 minus 8 is negative 2, which means there's a 2 on the bottom. That negative 2 power means that it's in the denominator, and then it becomes positive down there. Alright, so those are kind of an intro into polynomials, and we should actually look at more specific polynomial questions that we'll see in the next chapter. So as an example, you take a look at this. We call this thing a trinomial because it has 3 terms. We say that its degree is 3 because of their 3 power up there. Coefficients are 5, 2, and negative 7. Negative 7 because technically there is sort of an x to the power of 0 there. We don't often write it, but all numbers are technically polynomials. And the variable is x. So do one last one here. If you have 5x squared minus 100, there's 2 terms, so we call that a binomial. And the degree this time is 2 because it's got a highest power of 2. Coefficients are 5 and negative 100. Variable is x. And constant is negative 100, which I should have said. And for the other one, it's negative 7. Alright, thanks for watching.